Hey guys, I'm back. So, yesterday we did a lot of just basic derivation. Today, Professor Ken told me that there is quite a good number of resources on D2L, so we are going to look into some of those resources today. See if he's got anything fun for us to work through. Okay. All right. What's up, guys? So this is just from yesterday. I'm going to erase this before the session gets going here. Okay, so my phone is fully charged. My Wi-Fi should be good to go for today. Let's see how many people we're going to have here. So 2 right now, that's cool. All right, so I'm thinking for this session, I'm going to be using the group chat a lot more just so we can kind of interact with each other because I'm at work and I only have an hour break. Would it be okay if we leave early? Yes, it would. Yeah, you guys don't have to stay for the whole thing. Like, you can. I would highly recommend it, but it's going to be on YouTube, on my YouTube channel no matter what, so I wouldn't sweat it too much. All right, for the 2 of you that are currently here, is derivatives at a point fair? Yes, no? Does anyone want to work on derivatives at a point, or do you guys want to work on techniques of taking derivatives such as the quotient rule, or just do you really just want me to dive head first and kind of give you everything I can? Just give me a thumbs up if you want me to I've got some, you know what, I'm just gonna do it. We've got some derivatives at a point, so we'll use this little warm up here. Let's find a good one, why don't we? Okay. On x plus 3 x equals 5. Okay, so this is our first problem that we're going to start on. So we've got f of x is equal to the negative natural log of x plus 3. So f prime of x, if we follow the chain rule, should look something like this. Negative 1 over x plus 3 times 1. So f prime of x is equal to negative 1 over x plus 3. So now what we're going to do is we're going to plug in our 5 here. So we're going to get, let's see, negative 1 over 8. So this is the slope of our tangent line right here. So now if we want to find out the equation for the tangent line, Well, this is all we can do right now because they only gave us 1 point and that was an x value. But yeah, I mean, don't overthink these ones too much, y'all. They'll get you. Let's see. Yeah, so that's just -1/8. Gosh, you know what? I also have a very bad problem about overthinking things, and I think you guys watching me do it will probably be beneficial because I never had someone to tell me that there was a such thing as too much thinking in calculus, but I am here to guarantee you there is a such thing as too much thinking in calculus. So I'm feeling a purple marker for this next question. Let's do, I know you guys all hate trig, so I'll be nice and start on something a little bit nicer than trig. So we'll start with f of x equals 20 over x squared plus 5. At the point, let's see, x equals 3. All right. So we want to take the derivative of this. There's a couple ways we could do this. If you guys remember the derivative of a constant, like multiple, like if we have 20x, then that's just going to be 20, but all right, so this one, they clearly want you to do it a specific way. So let's see if I'm right here. So you guys remember yesterday, the quotient rule, f prime of x times g of x minus g prime of x times f of x all over x squared plus 5. So let's identify f prime of x, f of x, g of x. Maybe not for right now, but what was the difference between finding the derivative of dy dx and dx dy? So that's actually I can answer that really quick. So if we have dy dx, that means we're given a function y and told to differentiate in terms of x. So if we have something like, take the derivative, so this is just dy dx, right? So we'll say that y equals something basic, 5x squared. So this is the whole function for y, but we only want to differentiate with respect to the x value. So this would be like 10x, right? The first derivative of 5x squared is going to be 10x. But if we were given a problem that said, say, dx over dy, and they gave us 5y squared, then that would give us 10y. The only difference is we're differentiating in terms of one letter. So it's the same principles, the math doesn't change, but when you've got two different terms, is this dark? Can you guys see this pretty well? I can turn on lights in here if that helps. Okay, but yeah, the only difference is that you differentiate based on the letter that's on the bottom. The letter on the top is what the whole function should be. Does that make sense? All right, so now back up to this quotient rule right here. All right, so let's identify some factors here. So we got f of x equals 20, g of x equals x squared plus 5, f prime of x equals 0, and then g prime of x equals 2x. So let's just plug and chug now. Oh, almost forgot. See, I was checking if y'all were paying attention and no one caught it. So let's see, f prime 0 times g of x, which is going to be x squared plus 5, but it doesn't matter because it's multiplied by 0. G prime of x, 2x times f of x, which is 20, all over g of x squared. So this goes away because 0 times anything is 0. A light might help. It's not terribly dark. That's fair. I can try. Let me turn on 1 or 2. Here, this one will probably do the trick. Okay, so then this is going to give us, yeah, that's so much nicer. 40x or negative 40x over x squared plus 5 squared. So let's double check our answer real quick. All right, so our final step is to plug in 3 for x. So negative 120. Minus g prime x times f of x, 40x. So x equals 3, that'll go as negative 120 on top, and negative 9, 4, 16, so 120 over 16. And I'm almost 100% positive that can be simplified, so why don't we just divide a 4 out of both of them and see what that gives us. So is what not squared anymore? The bottom? No, it's still squared. G prime of x. F of x 20 all over that. So let's see what happens when we plug in 3. So 3 plus 9. Oh, there it is, mistake. There it is. My handwriting was the error. See, you should never try and do math in your head because, especially when you're doing it live, come to think of it. Sometimes it's fun to give it a try. So 9 plus 5 squared. So 14 squared, that's 196. So negative 120 over 196. You can simplify it. I don't think it's going to matter. It's probably going to give you, if you want to simplify it, it's going to give you 30, negative 30 over 49 is your final answer. And this would be slope. 16 squared then, right? Question mark. Not sure I follow on that one. Are you talking about the bottom? Because we're doing at x equals 3. So 3 squared is 9. 9 plus 5 is 14. 14 squared is 196. Does that make sense? I'm not quite sure what you're asking should still be squared. If you're talking about the denominator, yeah, but we have to plug in the x equals 3 value. So 16. Those are plus signs, by the way, not minus, if that's what's causing this here. All right, but yeah, this right here is the final answer for this. So this is just review from what we did yesterday. This shouldn't be anything terrible. I'll get to the terrible stuff in just a moment. But right now I'm just kind of doing this as a warm-up because I figure this is probably what most people are struggling with because this is what most people in my class missed. All right, that looks interesting. Y equals at, let's see, x equals negative pi. Okay, so next problem, we have y equals negative tan of 2x at x equals negative pi. We are asked to find the slope of the tangent line. So the first thing we're going to do is we're going to take the derivative of the function y with respect to x. So that's going to give us d dx for negative tan of 2x. And if this is confusing, you can always move the negative sign out front. But let's see, the derivative of tan is secant squared. Yeah. So we've got, let's see, we'll do some chain rule here. So secant squared 2x times 2, and then we can't forget that negative sign out front, is equal to negative 2 secant squared of 2x. So at x equals negative pi, let's see what we get. We get negative 2 secant squared of 2 times negative pi, negative 2 secant squared, negative 2 pi, which is the same thing as 2 pi, isn't it? Because if you think about it, unit circle here, 0 and 2 pi are the same thing, so negative 2 pi is going to be in the same spot as well. So negative 2 pi, let's see, secant, so that's going to be 1, 0. You know what? I was just about now wishing for my graphing calculator, but then I remembered, since the entire planet is on quarantine, that they made the graphing calculator app free. So I'm just going to do that. So let's see. Oh, that's still annoying, but let's see. 1 divided by cosine negative 2 pi squared. All right, and that's going to give us our final answer, which is negative 2. If we aren't allowed to have graphing calculator on the test, what would we do? Suffer? No, I'm just joking. So this is actually very easily derivable. I was just assuming that y'all probably wouldn't have too much trouble with this, but here, I can show you guys exactly what to do. So, all right, cosine at 1, or at 2 pi is 1, right? So if we take 1 and then divide it by 1, it's still going to give us 1. So what that means is we've got 1 squared. We can plug that in for this entire expression right here. And then we've got to multiply it by negative 2. And that's going to give us negative 2. So you can solve it quite easily without a calculator. I just wanted to show off my quarantine technology because I used to want that app for such a long time, but it was like $10 and I couldn't talk myself into it. But when all the schools shut down, I was like, oh, that's kind of neat. They made it free because a lot of kids don't have access to calculators and stuff. So I downloaded it. It's a personal favorite of mine. It's just as good as the TI-84 or anything like that. and it costs about $80 less. The only downside is that you can't use it on test. So let's do one more of these derivatives at a point, and then we'll move on to something a little bit trickier. Actually, you know what? I changed my mind. We're moving on to something trickier. We're going to do some difference quotient, because I know all of you guys love the difference quotient. I know that you guys just fall asleep repeating f of x plus h minus f of x over h with the limit as h approaches 0 is the definition of a derivative in instantaneous velocity. So I'm going to pull up this little worksheet I found. Let's see, this should work. Oh, where are the hard ones? Square root of x squared minus 1. Should we expect a lot of questions like this one in test? What you should expect on this test is a very basic covering of derivatives. Like this test, you shouldn't expect your world to end. It should probably be the easiest test of the semester. If you understand your basic rules of derivation, the difference quotient, your algebra strong, your trig is strong, this should be no problem for you at all. If you don't, well, it's the night before the test, so you might be out of luck, but I'm here and you've got some time, so x squared minus 1. But yeah, this stuff you should expect on the test. I mean, none of this should be too horrible. So let's set this up as a difference quotient. Limit as h approaches 0 all over h for so this should look quite familiar at this point. I'm sure it has been permanently fried into your brain, much to your disdain. So now let's do the next step here. So limit as h approaches 0. So we're just going to plug in. Let's see, square root x squared. Yeah, so this one right here might be an example of a question you wouldn't see on a test, actually, because no, so I would not expect questions like this. This right here, the reason I'm saying this and kind of the reason I worked it halfway through is because there's always one question like this, and it's like you'll run into this probably in a homework set where it's going to ask you to move the radical to the bottom, and that's going to be the final step. So if you can do it like the first few steps and then you know radicals, this should be fine. But I can't imagine any Calc 1 teacher I kind of saw during a summer class is going to put in a difference quotient with radicals, because they're actually quite like ugly problems. They don't simplify too nicely. But I know that those have been terrifying you guys, so I figured I would pull your leg a little bit. So now let's look for, here, you know what? This is actually a good segue here. I'm going to teach you guys, well, first off, I'm going to give you guys a really complicated, long problem that you're going to absolutely hate. Then after you've worked for a really long time and you feel like you've solved the problem, I'm going to show you how to solve it in half the time. with a much more difficult trick. Plus, most of the derivatives in this chapter are boring. So let's look at some chain rule stuff. Oh, here we go. So we've got f of x equals 5e to the 4x at the point 0, 5. All right, so this is going to be chain rule right here because they don't like you. These are the worst ones. You'll run into these in calculus too with integrals. And this type of problem right here is the one that people always forget, the e to the x, because you do have to apply the chain rule to e to the x, unfortunately. So if we've got 5 times e to the 4x, if we want to differentiate this, we're going to have to take out this 4 right here, bring that out, so now we're going to get 20 times e to the 4x, and then multiply it by No, we don't have to multiply by anything. So now what we're going to do is we're going to plug in our points. We've got 0, 5. So we're going to plug in 0 for our x. So we're going to get 20 times e to the 0th power, which is just going to give us 20. Okay, this is actually relevant to a question someone asked yesterday. So someone said, can you do that y is 0 minus y1 thing? And I will show you exactly what they were talking about. So this way, the way I've been doing it is I just take the derivative, plug my x, and then I use that to find my slope. So then after that, I go, okay, I know that y equals slope times x plus b, and I know that I have an x and a y value I can test. So I go, let's put in 5 here. 20 times 0 is just 0, so b equals 5. So the equation to the tangent line of this is going to look like this. 20x plus 5. Now, the other way you may have been taught to do it, which this way is probably faster but a little bit more difficult to understand conceptually, would be, let's see, if we've got something like y minus 5 equals 20, which is our slope, times x minus 0. So as you can tell, guys, like this and this are the same thing. I mean, like, if you distribute them, they're the exact same thing, and you still need to solve for the slope regardless, either way. So if you want an easier way to think about it, I would highly recommend thinking about it in 3 steps. Step 1, take the derivative. Step 2, plug in the x value. Step 3, take the slope from that plugged in x value and use that to find the y equals mx plus b form by just plugging back in the original coordinates like this. I mean, this is really as tricky as it's going to get for this test. Like, if you felt pretty comfortable doing something like this, all the problems are going to be around this difficulty. So I'll just go over a theorem real quick because I know this one gets skipped over quite often, and it's actually something that I don't know it right off the top of my head. So it'll be a good little refresher for me as well. So here you guys go. So if we've got the derivative d dx of some constant a to the x power, that's going to be equal to a to the x times the natural log of a. So this is just something, probably shouldn't seem too far off. It's just a little theorem that you might want to keep in your back pocket. because some professors do pull stuff like that, and you should always be prepared. Okay, let's see if we can find something that has more than 3 parts to it. No, you know what? I think chain rule should cover this. I'll do a real quick intro to derivative implicit differentiation. So if we've got something like, well, here, let me just pull up the first example. So if we've got 3x squared plus 4y squared equals 2x. So this actually isn't all that bad. We're just going to subtract 3x squared from both sides. So now we've got 4y squared equals 2x minus 3x squared. Take the derivative on both sides. That's going to give us 8 times y dy dx equals 2x minus 3x squared. Then we've got dy dx over here, so divide both sides by 8y. And oh, look at that, it simplifies even further. Yeah, and you can simplify this by factoring out like x or something, but did I just skip a step here? Minus 3x squared. Did the book skip a step? 4y squared. Yeah, but basically it's just taking the derivative with respect to y. So you probably won't see this on the upcoming test, but it's definitely something that you should keep an eye out for. All right, so I pretty much got what I needed to say out of the way. So I'm going to give you guys about 5 minutes now. If you have any questions, feel free to ask them. I'm just going to give you guys 5 minutes to type in case it takes a while, like you need to go to a math website to get a symbol or something like that. But we'll just take a little 5-second break and then, or a little like a couple minutes, just formulate your sentences and ideas and questions. You guys know how to ask questions. Okay, so no questions. Cool. All right, I'm willing to roll with that because that means I can choose them. So ooh, this one looks enticing. Let's try this guy. Give this like one time. So x squared minus 1 squared at 2 4/9. All right, so this problem right here shouldn't look too bad. I mean, it probably doesn't look like a lot of fun, but it's not bad. quotient rule and chain rule. Here, I'll show you guys exactly why implicit differentiation is needed. So if we just write this as y equals x squared over x squared minus 1 squared. So what if we took the natural log on both sides like this? Natural log of y equals the natural log of all of this stuff over here. That's pretty nice right there. So now if you guys remember your exponent rules, this should look pretty swifty here, because if we differentiate, then this is going to give us, well, first let's just look at our natural log rules even. I mean, oh, look at, like right here. Natural log 2 natural log, and then minus 2 natural log x squared minus 1 equals natural log y. Is the screen really blurry for anyone else? It might be. I can pull this closer. Oh, that's so much better. Does that help? Yeah, but this right here, just keep that kind of methodology in mind, because that is what's going to be on the next test. This right here, though, if you want to do it the way that it's going to be not a whole lot of fun, we can. But you know what? We've got nothing but time, so why complain when we have infinity time, because everybody is locked inside and we have math to do, so we can't complain too much. G prime of x is equal to 2 times x squared minus 1 times 2x. Okay. So, if you guys remember correctly, let's see, f prime of x, so 2x times g of x squared minus 1 squared minus g prime of x, which is going to be 4x times x squared minus 1 times g of x, which is x squared minus 1 squared, all over x squared minus 1 to the 4th, because we're squaring the bottom. So I'm sure you guys are like, that looks horrible. And I would agree with that. It does indeed look horrible. But you don't have to do all of it. I mean, you can simplify it if you really feel the need to. Like, if you really, really want to, you can simplify it. But we could also just plug in our x value. Ooh, that's a lot of math right there. Let's see, 4 minus 1, 3, 9. So 4 times 9 is 36 minus 36. 4 times 2 is 8. 8 times 3 is 24. Times 9 is possibly too big for me to multiply in my head. 36 plus 180, 216. Someone tell me if my math is wrong. I'm kind of just trying to eyeball it here, do it in my head. So then we do 2 squared 4 minus 1 is 3, 3 to the 4th power, so 3 to the 3rd is 27, so it's 81. So we've got 36 minus 216 over 81. Okay, so 36 and 216, that actually looks like it works out pretty nicely. So 180 over 81. And that simplifies. We can divide out a 9 from both of those and get negative 20 over 9. Please write the formula again. Absolutely. I was going to write it afterwards. I just wanted to see if anyone had it memorized quite yet. So f prime of x times g of x minus g prime of x times f of x over g of x squared. All right. I think I'm going to do 2 more chain rule problems, and after those 2 more problems, I think the majority of you are going to be overly prepared. So I think, honestly, I can work as long as you guys want me to work, but I don't want you guys to think that this session is meant to be your end-all be-all here, because the saddest thing about math is that you can have the greatest teacher on the planet, but if you don't do it on your own, you'll actually never get good at it, which is kind of what happened to me in high school. I was pretty good at math, but I was just really lazy. And that ended up being, I figured out that, shocker, if you do the homework, you'll get an A in the class, you know. But no, we have no time to be lost in nostalgia. Let's solve some more problems. So let's look for a real good chain rule for this one, or not chain rule. Yeah, it is chain rule. Next year, you're going to get something called U substitution, and you're going to constantly fumble between those two and not know what to call which one, because one is just the other one, but backwards. So, you know what? They tend to have pretty good examples. Yep, I figured they would. Here we go. Y equals 5 times cosine squared, of 3x plus 2. Yeah, see, this is why calculus has a hard time with itself, because they are switching back and forth between letters and stuff. Oh man, that's funny. Okay, so here, I'm going to teach you guys what is called the chain rule, but what appears to be a U substitution, apparently. So if we say, we're just going to call this cosine squared thing, we're going to call that U. So we'll know that cosine is equal to U, so then we can rewrite this whole expression as 5 times U squared. So this is the outside right here, right? So we're just going to take the derivative of the outside. That's going to give us 10 times U, because we're not changing this stuff right here. We're changing all the surrounding stuff. And then we're going to multiply by the derivative of U, which is 3. So that's going to give us 10 cosine 3x plus 2 times 3. Let's double check that. Oh, so close. So I had the majority of it right there. So we gotta take that 3 out, but you know what I forgot to do? There's 2 chain rules here. Check this out. So we can change this 10 here to a 30 for that. And then we got times, we gotta take the derivative of this as well. Negative sine 3x plus 2. So we can get rid of that and then just put that there and put this negative out front. So that might have been confusing to follow, so I'm going to go back and re-explain it. So let's take a look at this right here. So we've got 5 cosine squared of 3x plus 2. You'll never see something like this on a test, by the way. This is just me having fun. This is a good problem to know, because if you can solve this, I guarantee you'll make 100 on that test. But let's take a look. Let's take a closer look. We got 5 times cosine squared of 3x plus 2. So the first thing we're going to have to deal with is that cosine squared. So if we treat cosine as u, we can square u, and it makes it much easier to differentiate. So following the chain rule here, now we're going to go, okay, so derivative of the outside times derivative of the inside, which is sine of 3x plus 2, negative sine of 3x plus 2, then times the derivative on the inside of the inside. So this was like an f of g of h of x function right here. This one, you'll never see anything like this, but this is a cool little thing to just wrap your brain around. So with that in mind, I think I've got one more problem before we probably call it a day, because I think that this isn't, I don't want to use all of my hours just doing a session. So what I'm going to do is I'm going to have today be open for you guys to send me messages in the group chat. If you have any specific homework questions, anything like that, feel free to message me them after this session. I put a lot of thought in this, and I figured out, since I can't really use Microsoft Teams and YouTube Live at the same time, that it might be beneficial to do this more like a class homework type deal. But I'm not giving you homework because you don't actually have to do it. I'm offering you the chance to understand your homework here. That's the key word there. Use the chain rule for multiple composite functions. Yeah. Yep, that's exactly what we were just looking at. So you know what? Here, we'll do y sine, because the derivative of cosine is negative sine. d dx cosine of x was negative sine of x. So here, I can actually explain this quite well. So this is remember I was telling you guys about that f of g of h of x thing? So it turns out I wasn't making that up, and that was exactly what we were just doing. So we got dy du times du dv, I'm guessing times dv dx. Okay. So it's still going to be f of g of x, but now this time it's going to be more akin to, where this one is, what would this be written as? G of h of x. So I guess you would just write it as f of u, because we're plugging in u for u equals g of h of x. So this right here is what would happen if you had three different chains. There we go. And basically what they're saying here is that if you have more than one chain, you're going to have to use substitution, which I don't think Professor Kang will give you anything like this, but if you understand this and you can solve problems of this type with multiple substitutions, stuff like that, that means you actually genuinely understand this material, and you probably shouldn't be too worried about the test. If you didn't, I wouldn't sweat it too much. I mean, I would look into it again, but I think all of you guys should do fine on the test. From the questions I've been getting, it doesn't seem like there's anyone that just completely has no idea what's going on. So what I'm going to say now is that if you guys set aside some time in your day for this session, I would say use this next hour to just go work homework problems, because that will be more beneficial than me lecturing and showing you how to do these things. Because a lot of this stuff, like, if I show you how to do it 100 times, cool, but like, you still have to go do it 100 times. Because math isn't something that you can learn without repetition. And that's, I know a lot of you already know this, but I'm saying this because I know a lot of people, Calculus 1 can kind of be like a make or break class. But take your time, go slow, enjoy the process, draw every graph you see, write out every problem you see, work it forward, work it backwards. Take a big deep breath before that test tomorrow. And I am expecting probably a class average somewhere in the low to mid 80s because I'm pretty confident in this group's ability. So I appreciate y'all for coming out today. If you have any questions, message me in the GM or just message me directly through GroupMe. But thanks for coming out, y'all. Good luck on the test. I'll also be available right before the test if there's any last minute questions you need to ask. I do this because I used to have a friend in my chemistry class and she would freak out every time before the test, and she would always go and ask our SI leader a bunch of questions. So I figured that's probably a helpful thing to do for anyone that has test anxiety. So if you have a question right before the test, as long as the test hasn't started, I will answer it. Just for anyone that has test anxiety, because I know I went through that for a while. So feel free to contact me over anything in which you're going to have problems with, or any concerns, questions, comments, anything like that. I appreciate y'all for coming out today, and I wish you all the best of luck on tomorrow's test. So with that, I'm going to end on a high note, and we'll call it a day.